Bismillahirrahmanirrahim. Assalamu alaikum students. How are you? I hope you will fine. We are dealing with the Laplace equation in these days. We have studied the Poisson equation, we have studied the Laplace equation, its solution in spherical polar coordinates, its solution in rectangular coordinate, in cylindrical coordinates. But today we will discuss its solution in rectangular coordinates, in 3 dimensions, in 3 coordinates. In rectangular coordinates, the variable may be separated by making the substitution phi of x, y, z is equal to f1x, f2x, f3x. Means in rectangular coordinates, we know that there are 3 types of coordinates x, y, and z. And phi is the electrostatic potential, a variable in the Laplace equation, and this variable in the Laplace equation is written in the form of its variables phi x, y, z is equal to it, and we have separated this into its different 3 components f1x, f2x, f3x. These are being multiplied to each other. And Laplace equation is given by del square phi is equal to 0. Laplace equation is given by del square phi is equal to 0. We put just the value of phi from here in this equation. It will become d square phi over dx square dy square dz square is equal to d square over dx square dy square dz square into. Putting the value of phi from here into here, it will become d square into f1x f2x multiplied by f3x is equal to 0. After taking the derivative, making the differentiation and separating it into 2 parts, one is that consists on x and y components, and the second one consists on the z components, it will become 1 over f1x d square f1 over dx square, taking the derivative of this function, plus 1 over f2 d square f2 over dy2 is equal to minus 1 over f3 d square f3 over dz square. Basically, it was that this was on the left hand side, and the total of sum of the whole equation in terms of the differentiation after taking the derivative was equal to 0. So we have just brought the z component on the right hand side. The left side of this equation is a function of x and y, and the right hand side is a function of z only. This is the function of x and y, and this side is the function of the z only. Both sides must be equal to some constant k, because if this is equal to this one, and this is equal to 5, and this should be also equal to 5, and if this is equal to 100, this will be also equal to 100. The same constant. Both should be equal to one constant. That constant is k, and we call it first separation constant. So therefore, equation 2 will become, first of all, we take this part and bring this part equal to k. 1 over f3 d square f3 over dz square is equal to k, or d square f3 over dz square is equal to minus k f3. We are just over here, the f3 is being divided. Now on the right hand side, it will be multiplied. Or d square f3 over dz square plus k f3 is equal to 0. This will be our equation number 3. Now we will bring this portion is equal to k. We have made the left side equal to k. 1 over f1x d square f1 over dx square plus 1 over f2 d square f2 over dy square is equal to k. Or just bring this portion to right hand side, it will become 1 over f2 d square f2 over dy square is equal to k minus 1 over f1 d square f1 over dx square. So this will be our equation number 3b. So this term consists on y and x variable, x and coordinate. Our next task is to separate it into 2 terms. one containing one depending on the x and the second consisting of the y. So this equation number 3b has been written such that variable x and y are separated. Means in this equation x and y have been separated on the both sides of the equation. So to make it two different equations consisting of y and x, we will have to make it equal to some another constant, that is minus m. So each side of this equation will be set equal to minus m. It will be called the second separation constant. It will be called what? The second separation constant. So put this equal to minus m, 1 over f2 d square f2 over dy square is equal to minus m, or d square f2 over dy square is equal to minus f2, or you can write it as like minus m f2 on the left hand side. It will become d square f2 over dy square plus m f2 is equal to 0. This will be our equation number 4a. And now take this part and make it equal to constant minus m. K minus 1 over f1 d square f1 over dx is equal to minus m, or k should be bring on the right hand side. It will be, equation will be just like minus 1 over f1 d square f1 over dx is equal to minus m minus k, or it will be like this, minus negative on both sides will be cancelled out, and f1 will be multiplied on the right hand side. So it will become d square f1 over dx square is equal to f1 m plus k, or d square f1 over dx square minus f1 and m plus k is equal to 0. So equation 3a, this one, depending upon the z only. Equation 4b, 4a, consists only y. Equation 4b consists only x. We have separated it into the three coordinates of the rectangular component, rectangular coordinate system. So using these equations, the solution of the typical solution of the phi is written as phi of x by z is a expression minus a plus m power 1 by 2x cos of m power 1 by 2 y cos a power 1 by 2 c. So this was our task to find out the solution in the rectangular coordinate system. Thank you very much. If you have any question, you can ask me. And later on, if you have any question, you can ask me via my WhatsApp number is given in the description. Thank you.